Hello students, in this lecture we'll try some more theorems of gradient of a function and discuss algebra of gradient and also some very important result of gradient which will be used in the further study. The first one is show that total derivative v is equal to total derivative r vector dot total derivative of v vector. So let us take r be the position vector point on the level surface of a region. Then total r is equal to dr iota plus dyj dx iota plus dyj plus dz. Now take it left right hand side. Right hand side of dr vector dot del of v is equal to gradient of v is equal to substitute their values. We know gradient of v is equal to partial derivative v is equal to x iota plus partial derivative j vector plus partial derivative j dot product dot I dot I is equal to j dot j equal to other dot products are 0. Therefore, is equal to positive v to x dx plus positive v to y dy plus v z dz. This is equal to the total derivative v, which is the right hand side. Hence, proved. Now, if we u and v are two scalar point functions in a region, then gradient of u plus v is equal to gradient of u gradient of v, gradient of u minus v is equal to gradient of u minus gradient of v, gradient of u into v is equal to first function into gradient of v plus second function gradient of v. Gradient of u upon v is equal to denominator whole square, denominator into gradient of u minus u into gradient of and gradient of the sum of scalar point functions is equal to sum of their gradients. Now let's do the first. I'll prove the fourth part and other part will be proven by you. You can prove the parts yourself. So fourth part is we have taken left hand side. Gradient of u upon v is equal to gradient substitutive del is equal to del with x of u upon v iota del with y positive with y of u upon v positive z. So now this is equal to partial derivative of u upon v is to x formula of differentiation will be used here. The whole square denominator into partial derivative of x of u minus u partial derivative of v denominator to v iota. Similarly, partial derivative to y of u upon v is equal to denominator whole square. Denominator partial derivative of numerator is to x y minus numerator partial derivative to y, and similarly partial derivative of u upon v is to z. The same formula we applied in the three components. Now 1 upon v square is common. Now rearrange the terms. The term which has common factor as v, first term this and this as v common, and we are left with positive u which is 2x iota plus positive u is to yj positive u is to zk. Similarly, in the second terms minus is common, v u minus u is common, so we are left with positive v is to x iota positive v is to y j positive u, and this will become gradient. This is a gradient of, so v upon gradient of u minus u to gradient of v upon v square. Other part can be proved. Similarly, you can write here u plus v, gradient positive of u plus v equal positive u plus positive v, and then separate the components. Minus v similarly, product similarly, u into v is equal to positive v, component wise. The formulae of the gradient are behave like the differential coefficients. Just they'll behave like the differential coefficient ddx, differential to x or differential to y. So no need to remember these results. They are these formula same as the algebra of differentiation. See, you can do similarly the parts. Show that u vector dot gradient of v is equal to u vector. It's very important to note down and useful application in professor. And gradient of u vector dot r vector. Gradient of u vector dot r vector. Gradient we can find a scalar. You must keep in mind you can find the gradient of scalar is equal to a vector. U vector dot gradient of u vector is equal to u vector. Is u vector with the two features. Gradient of a vector dot r vector is equal to a vector, where it is the constant. Now we're proving into component form. Let u vector is equal to u1 at u2j. This is position vector 1 point. Position other point. U vector is equal to u1 at plus u2j plus u3k. R vector is equal to x at plus y2 yj plus z. Now we know u vector. U vector. We take the left hand side. U vector dot gradient of r vector. So u vector gradient of r vector is equal to u vector u1 at u2j substitute value dot gradient is this of r vector. So gradient r vector is equal to r is equal to x iota plus yj. Before positive is to x of x, you get positive x is to x I dot I positive of x is to x. How much is the value? So this is equal to this into you have to write del here also dot del of r vector. So this is equal to I dot I is equal to positive. This is u. This is scalar. This is scalar, and this is the vector, and this is a I dot I. The positives of I dot I same and positive r strings. Important step to be remembered here. This is equal to I dot I and positive of r vector. You're not supposed to put here dot product. Just remove this from here. Just remove it from here. This will be removed from here. So I dot I will get this thing of r vector. J dot J, K dot K of r vector. Now r vector, this vector gradient. This is positive. This is not a gradient now. This is a u vector positive r to x, u2 positive r to y. So positive r to y, positive r to y, and similarly u3 positive r to z. So positive r to x will be equal to how much? X is equal to x is equal to 1 iota only. So this is 0, positive y is to x 0, this will be 0. Similarly, this is equal to u2 positive of x is to y 0, positive this y is equal to 1, this is j, u2 j, similarly u3 this which is equal to u. This is very important step to be here. The this gradient can't operate on the vector. So first you have to solve this. First you have to solve this thing. You have to solve this thing because gradient can't operate on the vector, right? First you have to find their product. If product is not there, you are not supposed to operate the gradient on the vector. So that's the mistake I was committing here, and you should not commit this mistake. Keep this in mind. Keep this thing in mind here. Now let's go next step. Uh, let a is equal to a1 iota plus a2j plus a3k, where they are constants. So a vector dot r vector is similarly again I dot I, j dot j, k dot k is equal to a dot r equal to a1 x plus a2 y plus a3j. Now this is given. Now gradient can operate on this. So gradient of this is equal to positive of this a1x plus a2y plus j iota, a1x a2y plus j, a1x a2y plus j zj k, sorry, a plus partial z a1x plus a2y plus z total k. So when you find partial derivative from this partial to this to x, this constant will come outside, so this will be a1 only. And this partial is y0, partial y is to x0, partial z is to 0. Similarly, partial x is to this first term, partial x is constant, x is independent function, y is to y 0, y is to y a2, and the other is z is to y 0, only a2 will be here. Now similarly, partial is z of a1, a1x is equal to 0, a2y is equal to 0, you get a2 here, this will go here. It's very important vector and very easy to learn. Now, next question is, if r vector is equal r square is equal to x square plus y square plus z square. What is r? R is the position of the point in space. So the modulus of r is equal to root of x square plus y square plus z square. Then they prove that gradient of r is to n is equal to n r square minus 1 into theta. And proof is here. R square is given this. Therefore, r is equal to 1 root of this. R square n is equal to r square. You find the r left hand, take left hand side. So r square n is equal to x square y square plus z square into. Now take left hand side. Gradient of r square. Now this is equal to gradient of r square is equal to, so I tend to this is the summation, or you can write that in component forms. Summation means the summation here means these two component will find only first term, other term will be, because this is symmetric function. That's why we can do this. We can do this way or this way. So this is equal to iota partial to x of this alpha n by 2, j partial to y of alpha n by 2, k partial to alpha n by 2, sorry, alpha n by z. So if they take the first component, the same here, the first component here, this is it. So we are finding here all three components. So first component, then summation means we have three components, so we can write the similar way. I'm explaining this here, this step here. This is equal to n by 2, iota constant is equal to x n x y minus 1, n x y minus 1 into details of chain rule 2x, similarly for y, same for z. So this step is the first step same. This step is the first step same. Now this is equal to n, and this will be common factor. X square plus y square plus z square is for n by 2. N minus 2 by 2 is common. N minus 2 by 2 is common. This factor also, this factor also, this factor also. And three factors, we get n by n common 2 cancel. 2 cancel here, 2 cancel here. This is n into x square plus y square z square, and n by 2 minus 1 is common. You get x iota plus yj plus zk. Now what it is? This is a r vector. Now substitute the value of r vector here. This is equal to, now what is r? What is this? This is equal to r square n, and what is r? This for n. R square n is equal to n by 2. So we substitute here. You take the LCM and put x over y square is equal to n by 2. 1 by 2 is equal to r. So this is equal to r square n by 2. 1 by 2 is equal to r square minus 1 to vector r. This is vector r vector. Now vector r can be replaced by magnitude of vector into magnitude of vector into vector. So if you replace this by this, you get base is same. They are scalars. So n r square minus 1 r modulus, or something else, gradient of r square is equal to n r square minus 1 into vector r equal to r. So this we are asked to prove. This is equal to the now one more thing. Prove that a vector dot gradient of b vector, gradient of b vector dot gradient of 1 by r is equal to 3 a vector dot r vector, simple multiplication, b vector dot r vector upon r sub 5 minus a vector dot b vector upon r sub 5, where a and b are constant. Similarly, again, we take the left hand side and we do one step by step. What is R? 1 by R. Delta 1 by R. This is the formula. Delta of R is to N. N R is to N minus 2 by 1. This is the this is delta of R is to N is equal to N R minus 2 R vector. Or you can express that also. So generally we write in the vector form, not in component form. So substitute this value. So gradient of R is minus 1 minus N R to N minus 2 R vector. This is equal to minus 1 R vector upon R cube. Now pre-dot multiplying the equation first, both sides by B vector. So multiply B vector, pre-multiplying, because I told you vectors you never don't commute the things yourself, because cross product is not commutative. Whether we are trying dot product or cross product, we don't change the position of the quantities terms of the dot product. Now this we got the second step. Now this is second. Now next step is find the gradient of this. Find the gradient of this and gradient of the both sides. So gradient of this is equal to, we are taking help from the left hand side. Gradient of this is equal to gradient of this. Now gradient of this is a scalar. This is also scalar. This is scalar. So we can find gradient of the product u into v. Gradient of u into v, we prove the result. Minus gradient of this u gradient of v plus v gradient of u, right? Or you can write this simple multiplication. So in the case of simple multiplication, you can change out because they are real numbers. We know that gradient of b vector into r vector. We have to in the previous step. We have proved that gradient of b vector into r is equal to p vector. So b is a constant, and gradient of r square n is equal to n r square minus 2 into r vector. Now we are using this. So gradient of this will be equal to, now gradient of is equal to gradient of p into r vector is equal to p vector, and gradient of r square n is equal to n r square minus 2 substitute value. Now simplified. On simplification, we got the value of gradient of b vector dot that of vector. Now next step is pre-multiply by vector A. Multiplying both sides. Pre-multiply, finding pre-multiple of dot product of both sides of the equation 3. This equation 3 by pre-dot multiplying both sides by a vector. So a vector is equal to a vector dot is left hand side. So this is vector a dot b vector. Minus sign is there. Now this is scalar. So this is a vector dot. This is left hand side. Hence